What if the next major outage at Google isn't solved by a human first, but by an AI agent? In this video, we're diving into how Google is bringing agentic AI into site reliability engineering and what that means for the future of running massive-scale systems. We'll look at why traditional SRE workflows are being reimagined, how AI agents can support tasks like anomaly detection, incident investigation, and system management, and why Google is emphasizing transparency and control instead of black box automation. By the end, you'll understand how AI could transform the way engineering teams prevent failures, respond to incidents, and keep critical infrastructure reliable at global scale. So let's break down what SRE AI agents at Google are really about.
Welcome to this explainer. Imagine handing over the keys to the hyper-complex production environment of the world's biggest search engine to an autonomous AI. Well, today we're unpacking a massive shift happening right now deep inside Google. We're going to look closely at how their site reliability engineering, or SRE, is moving away from traditional deterministic automation and going all in on agentic AI. Here's our roadmap for today. We'll quickly hit the new system complexity, dive into the SRE AI architecture itself, look at AI anomaly detection, incident investigation, and insights, and finally, wrap up with the rules for these AI agents. Let's get right into it.
Starting with Part 1, the new system complexity.
Think about this for a second. For over 20 years, Google has banked on the discipline of site reliability engineering to keep massive, globally used services like Search, Gmail, Maps, and Cloud highly available. For 2 straight decades, that reliability-first mindset and traditional automation were all it took to keep the Internet's biggest engines running smoothly.
But those old reliable methods are hitting a breaking point. Why? Because modern systems are just ridiculously complex now. We're dealing with widely distributed microservice architectures spread all over the map, insane hardware diversity, and mind-bending enterprise topologies. But the real wildcard here is that last point. AI code generation has enabled developers to ship orders of magnitude more code than ever before. More code means way more opportunities for reliability issues. Because of this overwhelming surge in complexity, the old playbook just isn't scaling anymore. Google is making a massive pivot. They are moving beyond rigid deterministic automation, those static if this then that scripts we've relied on for years. Instead, they are pivoting toward dynamic, context-aware agentic AI that can actually reason about a complex problem and take autonomous action.
Which brings us to Section 2, the SRE AI architecture.
Google formally calls this initiative SRE AI. It is their comprehensive strategy to fully unleash autonomous agents as a true force multiplier, and not just during a 3 a.m. crisis, but across the entire software development lifecycle, from design and deployment all the way to incident mitigation. And crucially, they are doing this while maintaining incredibly strict operational control.
So, what's actually under the hood? At the base of this incredibly powerful stack, you've got Gemini foundation models, combined with custom models that are fine-tuned on Google's own internal data. Developers use the Gemini Enterprise Agent platform and the Agent Development Kit to actually build these solutions. But here is the secret sauce. The true magic happens when this AI stack is deeply, seamlessly integrated with Google's standard observability infrastructure. We're talking massive streams of live monitoring, logging, and tracing data. Add in the machine learning muscle of BigQuery and Google vector databases, and you have a rock-solid foundation for a truly autonomous system.
Now you might be wondering, wait, how do you safely let a massive language model touch live, highly sensitive production data? Great question. The answer is the Model Context Protocol, or MCP. Running on standard Google APIs, MCP servers act as the vital connective tissue. They are what actually allow these AI agents to securely shake hands with existing production tools and safely execute actions. Let's walk through exactly how this seamless loop works. Step 1, your standard observability infrastructure gathers the live logs, metrics, and traces. Step 2, the SRE AI agents securely access that data using those MCT tools. Step 3, the underlying Gemini models crunch those complex signals to truly understand the domain and the real intent behind the issue. And finally, Step 4, once the context is totally clear, the agent just goes ahead and autonomously executes the fix.
Moving on to Section 3, AI anomaly detection.
If you've ever been on call, you know the absolute misery of static thresholds.
like being jolted awake at 3 a.m. by an alert just because CPU usage briefly spiked to 90%. For diverse, highly dynamic cloud workloads, those hard-coded static numbers are practically useless. Instead, AI anomaly detection dynamically spots weird behavior based on historical signals. It focuses on actual, customer-oriented objectives rather than just relying on a dumb, hard-coded number.
The alerting pipeline here is incredibly smart and automated. First, the agent collects observability signals and pipes them into specialized models, like Times FM. When an anomaly hits, the SRE AI doesn't just page a human and call it a day. It triggers the alert, enriches it with all the vital context you'd ever need, and routes it directly to autonomous AI alert handlers. Handlers that can literally start addressing and mitigating the issue while your engineering team is still asleep. Next up, Section 4, Incident Investigation and Insights.
Google already has a well-established incident management process, known as IMAG. Now, SRE agents add a super-powered orchestration layer right on top of it. These agents autonomously consolidate messy data across chat spaces, they instantly generate shift handoff documents so the next engineer has total context, and, get this, they even automatically draft your incident postmortems. It effectively strips away the absolute most tedious, soul-crushing administrative work of a high-stress crisis.
Furthermore, to make sure these agents actually learn and improve over time, Google created a system called AI Insights. By leveraging Gemini embedding models in vector databases, this system continuously chews through known historical incidents. It's essentially extracting meaningful data and risk categories, constantly teaching the agents about the system's history. So, every single time they act, they make better, safer mitigation decisions.
And finally, Section 5, Rules for AI Agents.
Because, let's be real, this brings up a massive, terrifying core question. When you have autonomous agents that can literally change the state of production systems for billions of users, how on earth do you make sure they don't accidentally nuke the very systems they're trying to protect?
The answer lies in enforcing ironclad, high-level design principles. SRE AI does not get a free pass. It is treated just like a human employee. These agents have to comply with the exact same security, safety, and privacy policies as a human engineer. That means they get strong, assigned identities and highly restricted permissions. And yes, while they require continuous access to live production data to make accurate decisions, they are also continuously evaluated against a brutal quality framework. And crucially, there must always be well-defined manual backup contingencies in place.
Google's internal policy puts it perfectly. They favor transparency over black box automation. An SRE agent must always be able to explain, in detail, exactly why and how it performed a specific action. What alternative options did it consider? Why did it reject them? Black box automation, where the AI just acts without a clear, auditable trail of reasoning, is completely unacceptable in this environment.
Which leaves us with a pretty wild final thought for today's explainer. Google is actively proving that AI agents, powered by foundational models like Gemini and deeply plugged into observability stacks via MCP, can actually manage the crushing complexity of modern microservices. But as these autonomous agents master our most complex infrastructure and completely take over the grunt work, what new, impossible challenges are human engineers going to tackle next? It's an absolutely fascinating frontier, and one we will certainly be keeping a close eye on. Thanks so much for joining me today.